Morning guys, little experiment just to see if I can make the point on video, then tomorrow I can stay in bed. If it's not clear, of course, for you guys I'll come in. But I wanted to discuss, some of you may be familiar with this already, but I wanted to discuss how we show the hexaaquairon 3 ion being pale violet, because it doesn't help that our iron 3 solution that we have in our chemical cupboards is the chloride version, which looks distinctly yellow. Now, I explained the yellowiness by saying, well, the chloride ions are interfering. But what I'd really like to show is, I hope you can see the board there. I'd really like to show that the hexaaquairon is pale violet, and when we do the dissolving of an iron 3 salt, in this case the iron 3 nitrate there, when I dissolve that, we get this brown solution, which is the product of the first hydrolysis reaction. Now, if I just show you that with a test tube, and I get some of the iron 3 into my test tube here, and I dissolve it in water, then it's pretty clear from when you do this, it's pretty clear that that is brown. A little bit left at the bottom. Let's see if I can get it to dissolve. There. I hope you can see all of that's dissolved. See through it. It's a solution. All dissolved, and it's brown. Whether it's a function of the first hydrolysis reaction or the second one, it doesn't matter, they're both brown. The hydrolysis products are brown, and that's a brown solution. So, how do we show the pale violet? It seemed obvious to me that if it's an equilibrium situation like we do have, then I can manipulate it by adding acid. I can make it go that way. See, oxonium ions, adding acid, make it go that way. Or the opposite of that, clearly, if I add alkali, react those away, then the equilibrium will move that way by adding alkali. So I'm just going to play around with the equilibrium, and hopefully, fingers crossed, inshallah, we shall see. Watch. That is a little bit of nitric acid added. Can you see the colour, the brown colour has gone. If I add a teeny weeny bit more, because there is a little bit of brown left. That there, two observations. One, it's less brown, definitely less brown. Two, pale violet. Now some of you may challenge me on that. There you are. It doesn't look pale violet. But you know, when you compare it to the colour of the solid, there is a resemblance. It does give you a hint of pale violet that you can see. And the way I explain to my boys is, I say if I have a swimming pool load of that, it would definitely look pale violet. The reason it looks like this is it's so very, very pale in a small test tube that it's difficult for you to see the colour. Now, if I've got the equilibrium position on the left hand side, it's pale violet, then of course with alkali, sodium hydroxide, I can shunt the equilibrium the other way and it'll go brown. Put a little bit in, shake it up, bit more, couple of drops, shake it up. Then you can get back to the brown colour you had. And not only that, once you get back to the brown colour, you can add more, and you can get to the iron 3 hydroxide precipitate, which is what we've got going on there. So I suppose it's not rocket science, and I hope a lot of people are familiar with it anyway. So all I'm doing is manipulating the equilibrium to show the pale violet colour that they rarely see. And I hope that helps some of you at least. And I hope if the video plays properly, I hope then I can stay in bed. Thank you.